Hello friends, I am Ketan Kumar Gaikwad. Today we will discuss fundamental concepts of crystallography under the chapter Crystal Geometry and Structure. Friends, as we know, nature manifests itself into two forms, that is matter and energy. Matter is usually regarded to exist in three states, that is solid, liquid and gaseous states. As the atoms or molecules in solids are attached to one another with strong force of attraction, the solid maintain a definite volume and shape. The solid may be broadly classified as single crystal, polycrystalline, and non-crystalline, or you may say amorphous, depending upon the arrangement of atoms or molecules within the solid. The crystalline state of solid is characterized by regular or periodic arrangement of atoms or molecules. Most of the solids are crystalline in nature. This is due to the reason that the energy released during the formation of an order structure is more than that released during the formation of disorder structure. Thus, crystalline state is a low energy state and is therefore preferred by most of the solids. In single crystals, the periodicity of atoms extends throughout the material, as the case of diamond, quartz, or mica. A polycrystalline material is an aggregate of a number of small crystallites with random orientations separated by well defined boundaries. Most of the metals and ceramics exhibit polycrystalline structure. The non-crystalline or amorphous solids are characterized by completely random arrangement of atoms or molecules. The periodicity, if at all exists, extends up to a distance of few atomic diameters only. In other words, these solids exhibit short range order. Such type of materials are formed when the atoms do not get sufficient time to undergo periodic arrangement. Glass is an example of amorphous material. Most of the plastics and rubbers are also example of amorphous material. Friends, here is the example of honeycomb. In honeycomb, you can see the particular pattern is regularly and periodically repeated. Here you can see that hexagonal pattern is repeating. This is analogous to single crystal. Similarly, uh, similarly, you can take another example of pavement where the usually vehicles are parked. One can observe regular and periodic arrangement of tiles. Here, black and white tiles are arranged. Friends, before describing the arrangement of atoms in a crystal, it is always convenient to describe the arrangement of imaginary points in space, which has a definite relationship with the atoms of the crystal. This set of imaginary points in three-dimensional space with each point having identical surrounding is known as space lattice. The crystal structure is always described in terms of atom rather than the points. As shown in the diagram, you can see the example of 2D lattice. Here, the points are zero-dimensional points, means they are imaginary, and the motif is nothing but the atom or group of atom. When an atom or group of atoms are placed on each point of the 2D lattice, two-dimensional crystal will be generated. Thus, in order to obtain a crystal structure, an atom or a group of atoms must be placed on each lattice point in a regular fashion. Such an atom or a group of atoms is called the basis and acts as structural unit for the complete structure. Thus, a lattice combined with a basis generates the crystal structure. Mathematically, space lattice plus basis gives you crystal structure. Thus, a lattice is a mathematical concept, whereas crystal structure is a physical concept. In other words, you can say that lattice is translationally periodic arrangement of imaginary points, whereas crystal is translationally periodic arrangement of basis or motif. Here is example of one dimension, two dimensional and three dimensional Brevis lattices. See in first diagram at the topmost, one dimensional Brevis lattice is generated by considering an object J. This object J is repeated along horizontal axis with a distance A periodically. So it extends minus infinity to plus infinity. So such a type of lattice is called as linear lattice or one dimensional lattice. Below that there is example of two dimensional Brevis lattice. Here along horizontal axis A is the distance between two successive imaginary points, whereas B is the distance between two imaginary points along vertical axis, and J is repeated along X and Y, and hence two-dimensional space is covered. Such type of lattice is called as a plane lattice. And the example of three-dimensional Brevis lattice is as shown in the diagram. This is about lattice, basis and crystal structure. Thank you.